Hello and good day once again. In the last video, I've shown you how we created a truth table by constructing the equivalent circuit in circuit verse. And we ran through the different values of the input and recorded the output to our truth table so that in the end we were able to have a complete truth table given three variables. In this video, I'm going to show you the reverse process, the process by which we are going to create the logic circuit given a truth table. Without further ado, let us head over to our circuit verse and click the plus uh, sheet button. Okay, and then we'll try this. We'll name it a circuit C, being the circuit 3. I think that's the more appropriate. Okay, and then let me put the truth table which I prepared into a text annotation tool. Okay. This time we are given a truth table and we will construct the circuit. This is it now. Let us construct the circuit. Okay, the first thing to do is we can start with our output. Okay, this will be our output, and our label for this will be our. Okay, and then we'll start making connections for our three inputs. Here we have three inputs. We'll put the orientation down. Okay, and label direction is up. We'll name this as A. The label direction is up. And we'll just copy this. Then we'll just rename the labels. This will be our C. This will be our B. And let us just choose it. First, we will make a positive line or an uncomplemented line for each. So that will just stop to the bottom. Okay. And then we'll put for each line, we are going to put a complemented side. Okay. Do that again for the B. We click at the connection button. And then we'll do that again for the C. What we're going to do is to construct the sum of products form. Okay. First, let's rename this circuit sum of products. Sum of products form. Okay. So we're going to visit each term and look at the mean terms. Okay. So our mean terms are 1, 2, 3, 4. There are four mean terms. The first is 0, 0, 0. So a mean term is an AND of the variables. Okay. So therefore, we're going to use an AND gate. Okay. And the label direction, we'll put it up. This will be our not A, not B, not C. That's the first mean term. That is M of 0 because A, B, and C are zeros. And then we will extend the input size. So we'll connect this to not A. Will start to click not A. It's here. And then we'll connect not B. This is not B. Make sure we connect it correctly. And then we'll connect it to not C. Okay. So this is our direct. This will our label, and then we'll put 1, 2, 3, 4, 4 input OR gate. Which will be directed to our output. And then the main reason why I'm doing this now is So we can put a label to the first term. The first term is not of A because A is 0, followed by a not of B because it's B is 0, and followed by a not of C because C is 0. Okay, and then we'll change the orientation to up. Okay, now the second term is another 3 input and gate. We put it here with the label direction up. Okay, and then the input size to be 3. Okay, so this is 0, 0, 1. So only C is 1. Okay, okay. So A, we have a not B because B is 0, so we'll connect it here. Careful not to double connect. And then we will connect to a not A because A is 0. We're making a mistake here, so just change this. We know we're not A is, so we'll start here. Okay, so that's not A. So now we now label this as with the label up, we'll now label this as not A, not B, C, which is our third mean term, and we will connect this to our OR gate like that. Okay, so the next term is 0, 1, 0. Okay, we need another OR gate, rather AND gate. Okay, we can put it here, and the input size is 3. Okay, and we'll have a 0, 1, 0. So therefore, we'll have a C of 0. So we'll connect it to not C, and a B of 1. So we'll connect it to B, and an A of 0, which so we'll connect it to not of A. Okay, and then we'll connect this to the output. We made a mistake there. I hope we can correct this. No, we just have to delete the lines. Reconnect them at the same time together. Okay. The moment we'll connect this together. Now there's a connection, there's a red line, which means that there's a connection there. So we'll have to change this and our input size to be 4. This will delete. Okay. So we have a not of A, B, and not of C. This will be our the label direction to be upwards, and this is not of A, B, not of C. Okay, and then our last will which will be A, B, C. We'll have this. Our label direction is upwards. This will be A, B, C, and our input size is 3. We don't have the label, so we'll just type it again. And our direction is upwards. Okay, and then we'll connect this to A. It's A. Then the second one we connect to B, and then the third one we connect to C. Now we're ready to connect the outputs. You can just follow the grid lines, okay? Like that, you stop and follow the grid line, go downwards, and then stop, and then follow the grid line, and then connect. Okay, you can also do that here. We go to the right, we follow the grid line, stop, we go upwards, we just go upwards one more, and then start with the input, so it's easier that way. And then we follow this. Okay, so let's try this now. Okay, First is 0, 0, that's 1. Second is 0, 0, 1, that's another one. And 1, 0, that's another one. And 1, 1 is a 0. And we'll have a 1, 0, 0, it's a 0. 1, 0, 1 is a 0. 1, 1, 0, it's a 1. Supposed to be a 1. So we have a mistake. Well, let's try the 1, 0, 1 first. 1, 0, 1 is 0, and then we'll have 1, 1, 0. 1, 1, 0 is wrong. So which means that it's A, B, not C, which is wrong. Okay, A, B, not C. So this is wrong because this should be A, B, not C. So we'll just have to change this. Okay, we'll have to connect this to A. Okay, and then we'll have to change our label to A, B, not C. Okay, I determined that because 1, 1, 0 is wrong. There it is 1, and then we'll have 1, 1, 1. So now uh, we have the correct circuit, which we created from the truth table. Before I forget, let us export this to sample CB project B. I've saved it to my downloads folder. So uh, that ends our video. In the next video, I'm going to show you a tool that is used to create the circuit using the truth table without having to build the circuit manually. And at the same time, the tool will simplify the truth table so that the resulting circuit will be automatically simplified. Bye for now and see you in the next video.